Alright, hi everyone. I'm back for chapter 2 of my textbook. Um, so this chapter is on the scientific method, and there's one line that kind of sums up things for the scientific method. It is not one procedure or one type of equipment. Um, it's pretty much anything and everything related to science, and I think that really helps kind of explain how it works. Um, and it goes on to talk about like general approaches to science per se, and using intuition, like you're gonna like going with your gut or what feels right, which isn't a good idea. In science, it is actually better for us to really look into things and experiment and not take things at face value and think that, oh well, this works for so and so, so this is gonna work for me. I think of it a lot like buying stuff. You're not going to go and buy whatever your gut says necessarily if you want to make a lot of money, because your gut could be wrong. So it talks about two types of things that are used in empirical research, and that is direct observation and experimentation. Um, Observation is actually just taking like written notes about everyday activities. Um, Obviously, when you go to the doctor, he's going to be writing down all sorts of observations for you. If you go to a mechanic, they're going to write down diagnostically what is right and wrong with your car. And it brings up the idea of control groups, which are, if you're doing psychological experiments, you have a control group and an experimental group. And in a control group, you're not changing anything. This is just like how things are, as opposed to the experimental group, which you like with observation, it's easier to find things out that way than it maybe to do it any other way. It goes on to talk about experiments and dependent and independent variables. And independent variables are in the simplest studies. Um, blah. Sorry about that. Independent variables are what changes. The dependent variable is what you change in the experiment, and the dependent is what results you see from that change. Um, so yeah. Also, it talks about reporting in psychology, and you can't take what you see at face value. Like, actually, a great example in this book. As you can see, picture people running in this book. A good report would say that you see three people moving their running, or like moving their legs in fast volume, whatever. You can't make the assumption that they're racing, because you don't know. Just by looking at this picture, you don't know. And one thing that it does say in reporting is that it should be unbiased and objective. And this means that you don't take anything of yourself into it. If you're looking at something and you're biased in one way or another, like, your definition of intelligence is different from someone else's, and they ask you to help grade intelligence in their study, like you're going to be biased. And a lot of times people don't realize they're biased. It's really weird. Like, it actually happens more often than you think, that people are just they won't come out and say, oh yes, I'm biased against such and such. Like, it really isn't that easy to figure out. The next thing that it talks about is concepts, which are basically how we categorize things. Like intelligence, there are so many different ways to categorize intelligence, and it's just such a broad concept, and it could be anything. It could be how well you do on an IQ test. It could be how high your grades were in high school, college, etc. It could be how long you can balance a ball on your nose. I mean, obviously in that situation, seals would be a lot smarter than us, because they're going to be able to do that for a lot longer. And then a construct is a concept or idea. It's kind of the same thing that I just talked about. And you have to create an operational definition when you do an experiment, so that way you know exactly what you are measuring when you look at measuring intelligence. You know exactly what things you're looking for and exactly how you're defining intelligence itself. The problem with operational definitions is not everybody has operational definitions is going to be the same, which kind of sucks. Let's see. And then when you use instruments in psychology, you want to make sure that they are accurate, that they are calibrated, and that they are precise. You need those three things, because if it's not all three of those things, your test is going to be off, and that's not good at all. It's never good. It also talks about measurement, like if you're using some sort of equipment, you're going to be measuring something. You're going to be using that to measure something. And the main concern with that is validity and reliability of whatever you're using for. Validity is the truthfulness, and that's in quotes in the book, truthfulness of a measure. Something is going to be valid if it has very similar attributes as another test. Like if you create a depression questionnaire, it should score compared against the back depression inventory, which is a very highly ranked, highly accurate test. If it doesn't come across as like really similar, not necessarily similar, but giving same results as that inventory, your test isn't valid and there's no point to it. The other is reliability, which is it going to test the same thing over and over again? So a lot of times that's just done with retest reliability. You have a group take the test, wait, and then you have them take the test again. And if they get the same results or similar results, as long as they haven't had anything major happen in their lives, which I think is something that a lot of people don't think about. If someone's had like a crazy experience in their life between the two tests, then that's going to skew your results really bad. Like if it's a depression inventory in one person, it's completely fine before the test, and then in between the first and the second testing, a family member dies. Like obviously they're going to be a lot more depressed than they were the first time around. Let's see. The next thing it talks about are hypotheses. Hypotheses are an educated guess. That's the simplest, straightforward definition. Usually in an if-then statement. If this happens, then this will happen. And it's just a way of explaining things. And one of the best ways I've learned in research is when you are making a hypothesis, you want hypotheses, you want to make sure that you're trying to prove it wrong. It actually makes it a much stronger argument if you're proving it wrong as opposed to trying to prove it right. Hypotheses, and this is in italics, and this is actually really important. Hypotheses are not testable if the concepts in which they refer are not adequately defined. If you're testing something and you don't define it well enough, obviously you're going to have a problem and it's not going to come across correctly in your test. Also, hypotheses are unstable if they are circular. The example that the book gives is the best way to explain this concept, and that is if you put a hypothesis, children who have attention problems will likely have ADHD. Well, ADHD pretty much means that you have attention problems. So why would you make up a hypothesis about ADHD and inattentiveness? This doesn't make sense. And the last one is that a hypothesis also may be unstable if it appeals to ideas or forces that are not recognizable by science. It has to be observable, demonstrable, and empirical. And so obviously the concept of God is not science. It's not. God is not science. The idea of the unconscious, that's questionable to me in this definition, but that's just me. But yeah, it should be all three of those things. The next part of the book talks about the goals of the scientific method, which are description, prediction. I should really start writing myself notes about this stuff because I'm just doing horribly. Explanation. Who knows? explanation, and application. And basically, each one goes into why the scientific method is important. In descriptions refer to the procedures researchers use to define, classify, catalog, or categorize events in their relationship. They talk about defining different psychological disorders. Like, you have to have a specific definition for those. You can't just say someone's crazy. It doesn't work that way. And the next thing it talks about is it talks about 4 different things. This is actually one of our discussion questions. The nanomythic approach, which means, and I think I butchered the pronunciation of that, which means that you develop things for generalizations, like something may apply to most people, but not all people. And that's another thing in psychology, that most things apply. You have to have a little asterisk there saying they apply to most people, but not everybody. The next is the ideographic approach, which means they study the individual as opposed to the group, which is good to understand how certain things develop. It's really a great idea. And then next is qualitative and quantitative. Qualitative, the basic definition of these two is qualitative. You're using words to define things and show how things happen, kind of like your medical records. And qualitative is using statistics and numbers and equations to define how things happen. And that would be more of what you see a lot of times in research studies. And don't think that just because something's qualitative, it doesn't mean that it's as good as something that's quantitative. They're both very, very accurate. Prediction is describing events in their relationship, but kind of like to figure out how they happen. Let's see, and it talks about correlation. In psychology, there is no such thing as like a law. We don't have laws like science does, and that's because there's nothing that you can prove beyond a reasonable doubt. There are correlations, but there are no such things as cause and effect. It's impossible to get to that level in psychology. It's just impossible. When you're dealing with people, it's not like you're dealing with an atom or things like that. And this is straight out of the book again. It is important to point out that a successful prediction doesn't always depend on knowing why a relationship exists between two variables. Sometimes it just cannot be done. Let's see. Explanation, obviously, you're trying to explain why things happen. And it talks about causal inference, which is covariation of effects, a time-order relationship, and elimination of all possible alternatives. This is very important in psychology. Basically, you want to show that the two events do relate, that the difference, like that this event does cause this, which I said cause and effect doesn't really happen, and that there are no other reasons for this to happen, which happens a lot. Application talks about applied basically with research. Oh no, I'm running out of time, and so the next part is talking about scientific theory, construction, and testing. Theories in psychology are big. Like I said, there's no actual physical definition for anything. It says a logical, organized set of propositions that serves to define events. It's basically the best way to put it. Yeah, not much else about that. So if you want to know more, I'll put up another video. You probably don't, because I don't think anybody watched. Anyway, leave me questions. I'm going to put my reference for my book so that you all know. All right, talk to you later. Bye.